Right. So there is a GitHub repo I'll share here as well. And so feel free to grab it and pull it down. But the nice thing about this, I'll probably like jump through some of the steps quickly just because we have time constraints. So if you don't have things installed or you don't have an environment set up, that's absolutely fine. You can always come back and all the code and everything we talk about will be in this GitHub repo already. So yeah, the way that this is going to work. So there's a series of steps here. These are steps that kind of follow in a real world situation where we're trying to model some data, and then we try and query that data to get some information that we need, and then we have to then optimize that query for scale. And so this will be using Rails, it will be using Postgres as a database, and we'll be working with some active record concepts. So for those that aren't familiar with any of these tools, Rails is the framework for Ruby. That's really useful for building web applications. Postgres is a database, relational database, so MySQL, SQLite, are all like other examples of this. Active record is the model layer of Rails that essentially provides nice Ruby objects and interfaces for working with data, typically stored in a relational database, but not necessarily. So without further ado, so we'll, as a first step, just create an empty Rails project, and we go into a new directory. I'm going to move this. Right, so what this does is creates a new Rails project called Concurrent SQL Workshop. There's a number of arguments here. But essentially what it's doing is creating a bare bones Rails project, like no tests, no JavaScript, nothing like that, because we don't need any of this for our purposes. The -d Postgres SQL means that it's set it up using Postgres as a database. Ignore all the warnings. Right, so now we've got our Rails project, and we can do bundle install. Right, so we've got all of our gems there, and yeah, that's step one. So what we have are three different things we want to model, and I chose these because we have models similar to this at Clio. So yeah, essentially what is Clio? So Clio is where Kavita and I work, and we're a financial health app, and we try and engage especially young people to be more conscious of like where their money's going, how they're spending their money, helping them budget, and helping them stay in touch with their spending. And the way that we do that, so we allow people to talk to us via Facebook Messenger, and we also have an app for Apple and Android. And when we're communicating to people via the app, one of the tools that we use, is Firebase. Essentially, it's a tool provided by Google that allows us to push notifications to people's apps. And the interesting thing about Clio that I think sets us apart from a lot of financial apps is that it is chat-based, and so we have some artificial intelligence that tries to parse the user's intent based on what sort of message they're typing to us, and then we'll send an intelligent response back, ideally. And so I want to kind of model these concepts in the database, and so there's three kind of main concepts here, obviously very simplified. We have a concept of a user, and so we'll give them a name, an email, and a snooze until, but essentially that's if people don't want to talk to Clio, they can set a snooze until, and then we won't send them messages up until the time that they've chosen to snooze Clio. So the next concept we want to model is the message. So these are the actual text that the users are sending to Clio, and we want to keep a record of every message that's sent because it's actually really useful for us as a business, as an artificial intelligence business, because we're constantly refining and iterating on our machine learning models. And by having all of this historical message data, it helps us retrain and retrain and retrain so that Clio gets smarter and smarter and smarter. And then the last concept we want to model is the Firebase token. So these are essentially tokens that then allow us to send push notifications to our users. So there's not much to them. There's the token itself, which is just a bit of string that Google gives us when a user sets up Clio and enables notifications. And then there's an invalidated at timestamp. So if for any reason users no longer want push notifications, they can tell us. We'll set the invalidated at flag, and then we won't then send them push notifications anymore. Any questions so far? Cool. Right. So essentially, what Rails does, it's really handy, is it has these generators for models. And so the way the syntax works, you say Rails generate model, what's the name of the model, and then what are the different attributes that model is going to have and what data types are there. So a user has a name, string, has an email, also string, has a snooze until, which is a date time. And then, normally Rails also sticks in a created at and updated at timestamp, but for these purposes, we don't really need them. So I said no timestamps. So we will generate a user. And so we can kind of see what changes we made. I'm going to commit this. Oops. There we go. Right. So we'll generate our user. What have I done? Have you seen this before, Kavita?
I didn't realize user was reserved.
No, I must have.
You must have created it when you're testing.
Yeah, it's possible. Yeah, maybe I need to drop the database. Let me see if that will work. Rails db drop. Let's see if this does the trick. There we go. Oh, you've got to be kidding me. That's not in there. Well, anyways, let's see if we generate the message instead. It lets me do that. No, it is because I've already done it. But I guess where would it have references to this? Because it just created this project fresh.
And you've dropped your database.
Actually, do not. You can just use force, can't you? There we go. Cool.
Yeah.
Oh, goodness me. Right, so what's happened? So we've got our... Interesting. Just going to look at something quickly. Yeah, I have moved it. Right, okay. Anyways, so we've got our migration. And so essentially what this is it's a bit of code that tells Active Record how to create the users table in the database, what attributes it's going to have. So the attributes that we pass in via the command line you can see here. And then we'll do the same for our message model. And do that. Now we got this migration, and you can see that for the for the message model, we can actually create a reference to the user model so that every message will have a user ID in it, so that like the messages belong to the users that are sending them, and how that's represented. So we have a references user, and it's a foreign key which tells the database that this actually is an ID that's references another table. Right, and then the last one we'll do is the Firebase token. And then we got that, and we can look at this. That's here. Again, it has a reference to the user. Oh, cool. And then we will apply this to the database. So when we say this will create the database, and then we'll apply these migrations. Right, so it's complaining because I don't have a DB schema file. Essentially what that is, once you've run your migrations, Rails keeps a copy of the whole database schema in that schema.rb file for like quickly rebuilding your schema if you need to, which DB setup calls, but if you haven't run any migrations, that file won't be there, so you just need to run DB migrate instead, and that will set up your database. So we should now be able to see that database. So if we open that up, right, so this is connected to my local Postgres instance, and you can see there's a Firebase tokens table, a messages table, a users table, and then 2 tables that Active Record creates for us. We can see our migrations that have been run in there. And then, for example, users. This is interesting that there's data here, even though I deleted the database. Anyways, ignoring that. Right, okay. So what do we want to do? So let's say that we want to find users that have recently sent a message asking for help so that we can reach out to them. And this is like a common type of thing that we do at Clio. We have a lot of custom messages, and we have a whole copy team that are always writing new things to keep people engaged with Clio, and sometimes we make mistakes and we need to message users to let them know that like a bug might be fixed, or we also target users typically every Wednesday or Thursday, with some new promotions that we're running, things like that. So in this case, this is kind of similar to something that we do at Clio, which is find people who've recently sent a message asking for help, so we can reach out to them. So essentially, at the end of the day, we should have a list of users that we could then send an email to or send a message to, something like that. So what sort of criteria do we want to have? So we want to find users so they don't have notifications snoozed. They've sent us a message with the word help somewhere in the body, and they have a Firebase token that's not invalidated. And so, how do we do this? So Rails has a concept of scopes, and essentially what I like to do is to build named queries, kind of like named filters, if you will, for the data in your models. And there's a lot that you can do with them. So essentially, what we're going to do is write some scopes to match all of these criteria. And so what does that look like? So if we go to what I might do is this, reopen that. If I can find the file. I know what I've done, computer. I think I moved I moved the old project, but I've still got like terminal windows that are still sitting in that. So I'm trying to do something in, oh God. Right. So I wonder if I rerun.
No, it's fine.
I don't know. Anyways.
Oh, yeah. Actually.
Yeah. Right. Okay, nothing is there. Interesting. I really messed this up. Anyways, instead of that, we'll go into the previous project, and we'll just look at what's already there. Annoying, but. So we'll just go to this commit. Cool. So, cool. Right. So there's a few things we've done here. So we've got these 3 different models that we've generated, and we've added a relationship between these models. So we've said that the message belongs to user, we've said that the Firebase token belongs to user, and then the user, we've said, has many Firebase tokens, has many messages. What that gives you, if you open up a Rails console, is you can say user, so let's create a user first. There we go. Right. So we say user equals user. Create. Right, so we've got a user. So this lets you do user dot messages now, and it will go and try and find messages for that user. We're going to user dot Firebase tokens, and it will let you find Firebase tokens for that user. It also gives you some nice shortcuts like user.firebase tokens.create, which will create a Firebase token for that user. And this is, yeah, the Rails console is really useful for this because you can see exactly what it's doing in the database. So you can see it inserts record into Firebase tokens with the user ID of 1, which is exactly what we want to do. So that's what we get by doing that. But yeah, so we want to write some scopes. So looking at what we want, so users that don't have notifications snoozed. So I've created this not snoozing scope, and essentially we're saying find on users where snooze until is nil, so they've essentially never snoozed, or where the snooze until is in the past. And the syntax that you're seeing here is essentially it's saying for this column it's less than, and then this is I never remember the right name for it, but anyways, it's like a substitution, so it will essentially take the current date and chuck that in there when it goes to run the query. And that's really good practice when you're using where filters, because Rails will do some checks for SQL injection and things like that, rather than just like hard coding the string directly into the query text. There's also like Active Record provides some nice ways to represent time ranges, even infinite time ranges, but I wasn't able to get that to work with this. So I'd be curious if anyone else has. Sometimes I think it only works like if you're going from like today into the future. It doesn't work in the past. I was doing a bit of reading about it. Anyways, I was hoping that someone on the session might know. Right, so that covers off the not snoozing. What else do we have? So find messages with the word help in the body. So if we go to messages, so I've created the scope for help. And this is like really basic. It's saying where body I like means ignore case, find rows where the column has data that like looks like this. So essentially it's help, and then the percentages mean like wildcard. So it's essentially text where it has the word help anywhere in the string, ignoring case. And then have a Firebase token that's not validated. So if you look at Firebase token, created this got valid, and essentially is where invalidated at is nil. We don't check like whether invalidated at is in the future, because we don't really set invalidated at for future dates. So it's either invalidated or it's not invalidated, and that's why it's written like that. So how do we string these all together? So if we go back to user, so we've created this need help scope, and the nice thing that you can do is you can chain these scopes together. So essentially what we start with the user is not snoozing scope. You can also use scopes from your relations. So if we say here, join the user to their Firebase tokens and their messages, and then apply for those tokens and messages, filter users that have a valid Firebase token and filter users that have a message for help, that will do the filtering that we want. And then we also need to tack on a distinct tier. The reason we need to do that is because a user could have many Firebase tokens and they could have many messages. They likely will. And so if we didn't have this on here, you'd get the same user multiple times coming back from your scope. And so this makes sure you have a distinct list of users. And yeah, any questions so far on what we've gone through? Okay, so the next step is to get some data and see what these queries actually look like. And so I've created a really ugly data generation script. So I'm going to go and look at that. But essentially, is this rig task? And if we look at where that is, we've got a data.rec task that I created. So we ran generate a little, which generates data. So essentially 10 users. And what it does, it deletes all the data that we've got in the system. And then it creates a bunch of sample data that's meant to look realistic, but it's also meant to work for these examples, like to have the right number of records, so that when we're trying to run these queries, we get some interesting results back. So I won't go into details into like how all this works. It's not like my best work, but it does the job. So let's see now what we've got. So we go back to our database. We should have some users in here. Right. So I don't know why this. Here we go. That's better. 10 records, right. So there's 10 randomly generated users, and here are messages related to these users. They have a random amount of messages. Messages are random text here, and then we've got Firebase tokens. Some of them are invalidated, some are not, for some of our users. So that's what the data looks like. So now if we go into the Rails console, we can try out our scope. So we say user.need help. This will say that, okay, so there's 2 users that match these criteria. And so we can get them. And yeah, they're these 2 users. And what's most interesting here is Rails in the console will show you exactly what SQL ran to get these. And one of the nice things that you can do is explain. And this will tell you exactly what SQL and how the database actually executed that SQL. And this is really important, especially if you're working in a system that scales or will be scaling, because it will give you some indications as to how long until this query starts to get really slow. So like the nice thing here is there's only 10 users, so it'll be really fast, really, no matter how we do it. And we can copy that SQL and go into our database connection here. And one of the things that you can do with Postgres, not only can you do explain, you can do explain analyze. It'll actually run the SQL and give you information on how the database executed it and how long each of the steps took. And so there's like a whole presentation on what do these mean. And there's links to some Postgres documentation that explain a lot of this. I don't even understand all of it, but like I know enough to be dangerous. But essentially it's saying to get the data, it's scanned all the rows in the Firebase tokens table. It scanned all the rows in the messages table to filter based on the criteria that we set. It's then gone through and looked up users that match those criteria, found those users, sorted that list of users, and then came back to you. And so this cost is going to give you some indication, relatively speaking, of how complex that operation was in the database. It'll tell you about how many rows it will come back. It'll tell you about how large those rows are, and it'll tell you how long that actually took to run, because we did the analyze. And you can see it's really fast, like it's obviously less than a second, which is great.
Josh, I have a question here.
Yeah.
As you scale, if the script is not as performant for way larger scale, can you actually go and manually try to improve the performance of that script, or how does that work?
Absolutely you can, and that's exactly what we're going to do next. So it's a great segue as to what do we do? How do we tweak it so that it scales? And so we did this for a set of 10 users. So let's do exactly that. Let's do it for a lot more users. We say generate a lot. This will take about 30 seconds, but it will generate something like 10,000 users, and then there'll be 500,000 messages and 500,000 Firebase tokens, which is only getting to a medium-sized scale. At Clio, we've got something like 3-ish million users, and 500. I don't even know how many messages. Like probably in the hundreds of millions of messages, I'd say now. Do you know by chance, Kavita?
Not off the back.
That's all right. Cool. So if we then go back to our database, so now we've got a lot more data in the database. And if you recall, so this took less than a second. If we run this again, sorry, it took less than a millisecond. Now it's taking 145 milliseconds. Yeah. So it is 100-fold slower, and this is maybe all right if it's a query that you're running just occasionally, but if you're running this like hundreds or thousands of times a minute, it's going to really slow down your system. So like it might feel fast here, but if this is an operation that you're doing a lot, it could become very expensive on your database and slow you down. So what do you do? So yeah, we've done this. So if we look now at our explain plan, so it's doing now parallel scans, but it's still doing full scans on the table. The reason it's doing parallel scans, it's running this on my MacBook. The MacBook has something like 8, 16, a ridiculous amount of cores. So it's like splitting up that table and trying to scan it using multiple cores of the CPU, but it's still all the data in the table, which is expensive because it has to actually go to the disk and fetch all of the different pages on which the data is stored. So databases have a concept of indexes, which are data structures that make it really fast for the database to find the data that you're filtering for. How it works, it builds up a binary tree of the keys that you're looking for, and essentially those keys then point to the actual rows on the disk, so that I'm explaining this terribly, so that it doesn't actually have to fetch all of the rows from disk. It can just fetch the pages that have the rows that you actually care about. So it's a lot faster when you get it to work. So typically what we do when we're filtering on a field, we can create an index on that field, and the database will just start using it, and you'll get a performance improvement. And let's do that. So there's also generators in Rails for generating indexes. And how we can do that, so we can say Rails generate migration, add index on users, and we'll get a migration, and we'll need to fill this in. So we should say an index on users, and what that looks like. I'm going to cheat and paste this in. So that just says, yeah, add index to users on the Susan tail column, because that's what we're filtering on. We can also do that for the Firebase tokens. And we'll add the index to the invalidated at column. And we can do our migration, which will actually create the indexes in the database. So what's going to change? So when we run this, the plan that the database is going to use to get the data will change. The cost will likely go down. The time will likely go down as well. Your mileage may vary because obviously this is local. The database is going to cache a lot of data in memory, so you need to be careful when you're doing this type of performance tuning locally that there's other variables that come into play. But if anything, we should see the costs come down from about 8,000 or so today, and that is indicative of better performance. So yeah, it went from 8,000 to about 3,000. The time it took to run went down by a lot, but I suspect part of that is just because the data is in memory already, because we've run this query before. And yeah, it's changed how the query is run. You can see now, instead of doing parallel scans on the table, it's doing index scans, which is going to be a lot faster. And yeah, so we've made a significant improvement already just by adding 2 indexes. Indexes don't come for free. When you have a table with a lot of indexes on it, it takes more time to change the data in that table. But generally speaking, the more indexes that you have on the columns you're filtering, the faster your queries will be. Any questions?
Yeah, I have a question. So if you, let's say you decide to add an index to a table which already has millions of rows, what would be the most efficient way to add that index without it being very expensive or potentially locking the database?
Very good question, Kavita. I'm glad you asked. So Postgres has the concept of concurrent indexes. And essentially, what it means is that we'll do exactly what Kavita described. Build the index in the background so that if your query is, if your table is being heavily utilized by your application, any queries that are being run against that table don't have to wait for that index to build. That will kind of go on in the background, and sometimes it takes an hour, 2 hours, 3 hours to build an index, and that's perfectly fine. Postgres, if you use the concurrent feature. So yeah, that was a good question. Cool. So we didn't add an index on to the messages body. The reason why we didn't is because with text type filters, a regular index won't always do the trick, because the indexing looks at the data in the column from left to right. And so if you're looking for something in the middle of the column, in this case we're looking for the text help in somewhere in the middle, it won't actually be able to use index because we're not actually looking for help from the beginning of the string. But Postgres has something to help us with that. It's called a gin index, and I'll let you read about it. So there, but essentially what it does is that, for example, for text-based columns, so this is string data, but it could be JSON data as well. You stick this index on, and it will break the text into little 3-character bits, and it will kind of map out where the rows that have these little bits of text, and so it lets you efficiently search within for text within strings. These indexes are pretty big and expensive to build, but they can be really helpful for situations like this. And we can build one, and you might guess that I have a magic migration that does this for us. And it takes a couple of things. So one is that it requires a Postgres extension, but it's surprisingly simple to install Postgres extensions. And you can see this is how you do it. I'm going to create a couple of migrations to do that, and I might cheat and just do it in one migration because it's faster, but best practice is to do these in multiple migrations. And the reason why it's best practice is because if any one of these steps failed, you want to be able to either pick up where you left off or roll back. And if within one migration step, if you have one bit that succeeded and one bit failed, you're kind of stuck because you can't roll back because your migration is only partially done, but you can't roll forward because you can't still finish that migration. So it doesn't leave you in a good state. So essentially do as I say, not as I do here. And so if you need to add an extension, this is how you can do it. In a Rails migration, and if you want to add a gin index, this is what it looks like. So you say add an index to messages body, op class. This means how you want it to represent the index, and it's something like gin trigram ops. It's to do with how it splits up the text in the index, and using gin, which is the type that we want to use. So we can run this migration, and it will take a little bit because it's indexing a lot of data. Cool. So that's there now, and in theory, we should see an improvement if it decides to use the index. It may or may not always use it, but let's see if it does. Didn't use it. anyways, the database will decide whether or not to use indexes based on stats that it generates on the table. We can tell it to refresh the stats by doing this command. No, doesn't make a difference. But anyways, that could, in theory, also speed up this bit of the query. So moving swiftly on, we can rewrite this query to be more efficient. And this is really important. So I'm going to show another version of the same query. And I'm going to talk through how it's different. So essentially, this original query that we have, it's going to users, it's doing a join on Firebase token, and it's doing a join on messages, and then it's doing some filtering. The thing with this is, because there's many Firebase tokens per user and there's many messages per user, we have to put the distinct here to then, once we've gotten all the matching users, to make it so that it's unique users. That's an extra operation, and it's a sort operation. These can be expensive. In fact, you can see right here, this is where the sort is happening. There's another way to do this, and the way that you can do it is, rather than joining directly to these other tables, you can write a filter against these tables, and it won't actually make then increase the size of your result set. And the way that you do that is you use a where exists clause. So you're doing a very similar thing, but instead you're saying only pull back user records that where there exists a Firebase token, where that Firebase token matches the user ID, and the Firebase token validated data is not null. And we're doing the exact same pattern for messages. So where there exists a message where that user ID matches the user ID here, and it has help in the body. And this is a common pattern that we use at Clio, and it's sped up our queries. And I personally think it makes them a bit easier to read, but that's completely personal preference. So let's look at the explain plan for this one now. So if we look at the query up here, we're getting costs of around 3,000. Let's see what we get now. Okay, we got a cost from between 4,000 and 3,000. So it is an improvement, and why that's an improvement is that we got rid of a sort operation, but we also and it's also completely changed how it's decided to run the query. So that is another technique that you can take if you've got a slow query, is you try writing it a different way, and see if that makes a difference in how it runs it. But now we need to take the SQL and actually plug it back into active records so we can use it. What that looks like, I will show you. So go back to user. So essentially what I've done here is created some more scopes on the user model. So scope for valid Firebase token and a scope for message for help. And essentially what it's doing is it's creating those exists clause for you. So it's saying Firebase tokens that are valid, you have to unfortunately stick in this where users ID equals Firebase tokens ID. Normally Rails generates that for you, but in this case, it doesn't have a nice helper for exists clause. And then we have to tell active records to stick in exists at the beginning of it. But essentially that's how you represent that in active record. And then what it means for our need help scope, it gets quite a bit simpler because now we're chaining our not snoozing scope with our valid Firebase token and message for help scope. So if we want to see that in the console, we can say user.need help, and we can see how many that brings back. So 133, and we can see our new plan there. There it is. That was really fast, but yeah, any questions?
Not sure there's a lot of time for this, but do you think about performance improvement just writing the most efficient kind of code, or are you saying we're going to see how the user base or the database kind of scale up, and then see if there's a need to improve script?
That's a really good question, and I think there's a couple of ways to look at it. So, like, yeah, one way you can look at it is, do you spend a lot of time up front trying to optimize it when you don't even know if it will need to scale? Like if users will want a particular feature that you're writing the SQL for or something like that. So, sometimes it's better just to write something, get it out there, put some monitoring on it, and just see if it gets slow later on. And then there's another approach, which I think you might be alluding to, which is around readability. Sometimes it's easier to write some code so that you or future developers can see, for example, the active record scope and say, oh, I know exactly what that's doing. And yeah, maybe it's a bit slower, but sometimes it doesn't matter that much, or it's more important that it's maintainable in the future. And then yeah, sometimes you've already got a scaling problem, and then you write some really ugly scopes because it's like so important that the query is fast. So it becomes a judgment call. But for us at Clio, we typically try and approach things and say, don't spend too much time on it, performance tuning. Like, just get something out there so we can get data on it, get information on how users are using it, and then come back and optimize if and when you need to. That's a good question. Yep. All right. If there's no other questions, I will leave everyone to go on to the next session. But thanks again for coming. And if you do have any questions afterwards, don't hesitate to give me a shout. Bye, everyone.